Hi, my name is Neil Mitra. I'm a research fellow at Lenox Hill Northwell Health. I want to thank SAGES and the moderators for the opportunity to present our research. The senior author has carried out investigator-initiated studies with these companies over the past 2 years, but the study that we're presenting was done without any interaction or support from industry. So full-thickness perforations are a complication that can occur when performing ESD or EMR. When they occur, surgery is usually required to repair or resect the large bowel. The importance of the submucosal lift, the tall lift is essential in performing an ESD or an MR. When a lift is created by injecting the solution to the submucosal plane, it helps separate and expand the layer and separate the polyp from the deeper layers of the bowel wall. This allows for a lesser chance of perforation, as well as creating the plane for which dissection will occur. With regards to lift establishment, there are 3 principal ways to inject the bowel wall, the most common being a sclerotherapy needle, which is used to mechanically penetrate the mucosa. The second is a high-pressure catheter system, which can be used with either a mechanical pump or a machine pump in a punctureless injection mechanism. And finally, there is a combination needle knife injection catheter, which allows the lift to be refreshed without instrument exchange. With regards to injection, the goal of injection is to establish a submucosal lift which expands the layer in which the dissection will take place and reduces the risk of perforation. But what we have found is when the deeper layers are injected, mainly the muscularis propria or the subserosal plane, they too can expand and lift the mucosal polyp. With regards to deep wall lifts, stable deep lifts can be made and be confused with superficial submucosal lifts. If an ESD or an EMR are attempted with a deep lift, it can be very hard to find and stay in the intended submucosal plane. Deep lifts are more likely to occur if a sclerotherapy needle is used. Deep lifts tend to be less distinct. They're shorter, wider, in contrast to submucosal lifts, which tend to be tall, round, and very well circumscribed. With regards to how deep lifts form, when you puncture the mucosa with a sclerotherapy needle, a strong thrust is usually required because the needle tip may slide on the mucosal surface. Because of that, the needle tip ends up initially in a deeper layer, and therefore the primary lifting occurs in that area. When injecting with the sclerotherapy needle, you want to slowly withdraw while bringing the needle more superficially in order to make sure the fluid ends up in the correct plane. When you see that the correct plane is lifted, you hold the needle there to make sure that that plane is lifted correctly. Here we can see a human case with a lift injection being made in the rectum. We can see with the initial lift, the lift is like diffuse and shallow, followed by a more superficial and tall lift as the needle was withdrawn. This is another example of a double lift in a bovine colon case. So here we see the sausage-shaped deep lift, and then as we withdraw the needle during injection, you see this well-circumscribed lift forming on top of that, which is what we feel is the intended lift or the desired lift in any ESD or EMR. With regards to experiment methodology, we decided to first use square pelts of bovine cow colon, and we would inject to create a lift. We then measured the height of the lift and then compared it to the baseline height of the mucosa. We then dissected the lift with a scalpel and then evaluated the cross-section to determine what layers were lifted. Here we can see a submucosal lift being made in the bovine colon. We see it's tall and well circumscribed. And then we see a cross-section here that we made of a superficial lift that shows a submucosal layer being expanded. Here we have a histological cross-section of a superficial lift, and we can identify the dye from the lifting solution in the submucosal layer. And then I believe we have another example and here's another example of the same, you can see the dye expanding the submucosal layer. Here on a gross, we did a mixed lift. We see in the cross-section that the mixed and superficial you see the muscle fibers below the submucosal lift on gross, and then in the histological cross-section, you can see the dye present in both the muscular and submucosal layer. In this lift cross-section, it shows the expansion of the subserosal layer in addition to the submucosal and muscular proprial expanded layers. The muscular propria and the submucosal expansion are more diffuse and less localized than a primary submucosal enlargement. And here we can see a lift dye in all three layers, submucosal, muscle, and the serosal plane. To get some idea of how much elevation is obtained from a deep and superficial injection, a study was done using the ex vivo bovine colon model. Bowel thickness measurements were made after intentional deep lift and superficial injections. Cross-sections were then made to confirm which layers had been expanded. Here, this figure shows a lift breakdown of the contribution of deep and superficial expansions to the mucosal lift in 16 different bovine specimens. This study helps to verify that a stable deep wall lift can be made and a deep wall can notably expand and raising the mucosal polyp. Deep wall expansion should help minimize the risk of a transmural perforation by further thickening the bowel wall. A widened muscularis propria could sustain a superficial partial thickness injury without the risk of perforation to the bowel wall. In ESD or EMR, intentional deep wall lifts would only make sense in conjunction with a good submucosal lift, which is critical because that is the intended plane of the dissection. Intentional deep lifts make sense late during ESD cases because it becomes harder to refresh the submucosal lift when a polyp is mostly detached. Also, a submucosal lift duration is shorter when compared to the case's start. Therefore, intentionally injecting the deep wall as well as refreshing the submucosal lift is logical to help prevent perforation. Here we can see in the bovine model, we're injecting in a polyp during late-stage ESD where it's mostly detached. The deep wall is being intentionally injected prior to the final incision. The exposed muscular surface can be seen to expand in response to the injection. If during the detachment the muscle is injured, perforation is less likely. And here we have an additional clip of an injection being made directly into the muscularis propria in a bovine colon after an ESD has been performed. Expansion of the deep layers can be clearly seen. To summarize, the muscularis propria and the subserosal plane can expand when injected. When a sclerotherapy needle is initially inserted, the needle tip resides in the deep wall. The initial injection may expand the deep wall and create a stable deep lift, which could be confused for a submucosal lift. Prior to an ESD, a lift must be critically assessed to be sure that the lift is submucosal. If not, a more superficial injection will be needed. Intentional deep wall expansion in conjunction with a submucosal lift should decrease the chance of perforation in ESD or piecemeal EMR. This makes sense, especially later in the case, and the authors now are using this approach clinically. Thank you. I'll take any questions.